Number 7, kind of doubling up today, aren't we? If we're given the function f of x is equal to the square root of x plus 3, they want us to figure out what restrictions might there be on the inverse of this function. Well, first let's find the inverse. So to find the inverse, the first thing I do is I write down the the square root of x plus 3, right? I just replace the f of x plus with a y. So I say f of x is equal to y, and I sub that in. Step 2, we're going to take the x and y values and we're going to flip-flop them. So now this becomes x and this becomes y. Step 3, I solve for y equals some stuff. So how do I get rid of the square root? What's the inverse operation of square roots? Squares. So I'm going to square this side. Whatever I do on one side, I have to do to the other. Well, I get x squared here is equal to just the base, which is y plus 3. I'm trying to solve for y, and so if I minus 3 from both sides, I get y is equal to x squared minus 3, or f inverse of x is equal to x squared minus 3. Now, are there any domain restrictions on that? No, not really. Want to see something cool?
Sure.
Wait, was there a domain restriction up here though on the original function? Yeah, there is. The domain restriction, that's a square root, so it's supposed to be, our domain restriction is x plus 3 has to be greater than or equal to 0, so x has to be greater than or equal to negative 3. Is there any domain restriction on the inverse function? No, but you'll find that when you go to graph this, that your domain restriction becomes the range, which makes sense, right? If you're flip-flopping the x and y values, the domain becomes the range and the range becomes the domain. So just keep that in mind.